In this video, we're not going to look at dividing a whole number by a fraction like we have in the previous videos. We're going to look at how do we divide a fraction by a whole number. The process, whether we model it or whether that we go ahead and use the standard algorithm and multiply by the reciprocal, is exactly the same. It's just we need to make sure that we understand what we're really looking for. Okay? If you will remember, when you divided a whole number by a fraction, your quotient ended up being a bigger number. For example, if you want to know how many 1/3 pieces you would get out of 3 wholes, that was 3 divided by 1/3, which was the same thing as saying 3 times 3, you got 9 pieces. Our quotient 9 was bigger than our dividend. Okay? When we start to take fractions and we divide it by whole numbers, we move back towards that the quotient will be smaller pattern. Alright? So first let's make sure that we're clear on the understanding of what we're doing. I have as an example 3/4 divided by 3. And I have a model of 3/4 already there for you. Okay? The blue sections, I've tried to make sure it wasn't overwhelming with what we were going to do and what I'm limited to with an expo marker. The important part here is that what we're going to try to do is take 3/4 and split it into 3 sections, which don't try to split it vertically. This is where we start to split it horizontally. So I'm going to draw in horizontal lines that are roughly going to split it 3/4 into 3 sections. Okay, and I apologize, coloring on that can be a little difficult. So now what we've really done is we've taken this whole that was split into 3/4. 1, 2, 3, 4. That was split into 4ths, excuse me, and we only colored 3/4. And we split it also again into 1/3. So there's now 12 total boxes. 4ths multiplied by 1/3 gives us each box is worth 1/12. But that's not what we want to know. We want to know what happens when we take 3/4. What's the value of taking 3/4 and dividing it by 3? So the 3/4 divided by 3 now means that each 4th has 3 little boxes in it. Because 1, 2, 3. Okay? But that's not 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. There are 9 pieces in 3/4 out of 12 pieces because the whole got split. We actually have 12 total pieces because we took 4ths and divided them in 1/3. There's 1, 2, 3. That would be the 3/4, 3 of the 4 columns split into the 1/3. 3 pieces out of a total of 12. Okay? Now, to what we did with our model, we just took 3/4. We know when we use our algorithm, that means we multiply by the reciprocal. 3/4 times reciprocal of 3 is 1/3. Multiplication of fractions, numerator times the numerators is 3. Denominators times the denominators is 12. That shows what our model is, 3 out of 12 pieces. We can simplify this and reduce it to its lowest terms. 3 and 12 both have 3 as a common factor, which equals 1/4. It's interesting and a little hard to see if we look at it like this. But 3 pieces out of 12 is 1/4. You might not visually be able to see it when we do it here, but here's a second set of 3. Here's a third set of 3. And then here's the 4th set of 3. But we also notice that 1, 2, 3, 1, 2, 3, 3. So when we take 3/4 and divide it by 3, the value ends up being 1/4. Each piece is worth 1/4. do it again, except this time let's take 2/3 and divide it by 2. Let me model 2/3 first. I'm going to split my whole into thirds. Here's 2/3. Colored in for you. Now, we want to take this 2/3 and split it in 2. 2/3, I'm splitting into a top section and a bottom section. But I also have to split the whole, which means I now have 6 parts to my whole. Well, if my whole is 6 parts, even if my original is 2/3, my denominator is going to be 6 no matter what. So what's the value of 2/3 if I split it in half, in 2s? 1, 2 out of 6 parts. Okay? Let's look at the algorithm. 2/3 divided by 2 is the same thing as saying 2/3 multiplied by 1/2, multiplied by the reciprocal, which equals 2/6. We can reduce this to the lowest terms. Divide by 2, top and bottom, and get 1/3. Okay? There's one set of 2, second set of 2, 3 set of 2s. We only need the value of 2/3 divided by 2 is 1/3. Let's look at 2 more examples. There's going to be times when we have to trust the standard algorithm. It's more efficient. I'm going to give you one of those right now. 7/10 divided by 4. I got a big old rectangle, one whole, that I'm going to split into tenths. There's 5/10. Now we got 10 parts. If I look at 7 of those parts, that includes, guys, 1, 2, 3, 4, 5, 6, 7. Okay? Now I want to split those 7/10 into fourths.
To thousands taking part in the Pope's daily live stream. Religious services among the gatherings banned in Britain for the next 3 weeks. French official.
Sorry about that. It was a news update. So if I take this 7/10 and I split it into 4 pieces, divide it by 4, now I have 1 row, 2 row, 3 row, 4 rows. But I got to go all the way through the hole. Now I have a lot of little parts. Okay? Matter of fact, 10 columns by 4 rows, there's 40 parts there. And I got to figure out how many I got colored in. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28. That's 28. Whew! So 7/10 into 1/4 is 1, 2, 3, 4, 5, 6, 7 of those. 7 out of 10, 7 out of 40 parts. I have no idea why I just counted to 28. 28/40 is equivalent to 7/10. 7/10 divided by 4 equals 7/10 multiplied by the inverse, or the reciprocal, which equals 7/40. Now, 40 is not a prime number, but 7 is. 7, 14, 21, 28, 35, 42. This is in its lowest terms. That model's really messy, so we got to eventually trust the efficiency of the standard algorithm. So let's do it again. No model this time. Standard algorithm. Take the reciprocal of 8, which is 1/8. Multiply those two together. We don't ever take the reciprocal of the dividend. 3 times 1 is 3. 4 times 8 is 32. 32 is not a multiple of 3, so therefore it's in its lowest terms.